Right.
same thing with almost everything, like customer service. Yeah, you won't be doing tickets anymore, but you'll still need to handle the escalations. And if for a company who really wants the customer experience to be good, you're going to have better interactions, and that'll require people. And you're going through all
Yeah.
these different jobs, like project management. You won't be doing the day-to-day tasks anymore. You'll be
Yeah.
managing at a higher level.
Yeah.
So all of that was pretty cool. But he mentioned the importance of the RAG and the vector database and how you set those up, right?
Yeah.
And so then I realized I knew at a high level what RAG was, but I didn't really understand how the database worked. So
Yeah.
I spent 3 hours this week on just one interaction with. I told AI, teach me RAG, start with a high level, and let's delve deeper and deeper and deeper into it.
Yeah.
And so I got the idea of it's a vector database. And like a vector, what is that? Well, in three-dimensional space, you have an X, Y, Z, and you create an
Yeah.
arrow from the origin, and that's your vector. Right?
Yeah.
It's an
Right.
arrow
Mhm.
pointing it. I said, great. But we're talking about databases that have 1,000, 2,000, 3,000 dimensions,
Yeah. Yeah.
right? It's not three-dimensional space. And so we got to get away from that. You've got to be able to say, okay, it's multi-dimensional space, and it's not like the multiverse in multi-dimension. It's just, you know, X, Y, Z, time, whatever other things you would normally put into a multi-dimensional. It's like we're measuring, and so then you're measuring words, tokenized words against other tokenized words, or
Yeah.
chunks in this case. And you're saying, how close are they? Are they pointed in the same direction as far as the vector? Because that means they're kind of aligned. How close are they in that 1,000-dimensional space? And it turns out the math we use for three-dimensional space works fine for 100-dimensional space, for
Mhm.
1,000-dimensional space. So the math is the same. So if you get away from thinking about it as, or maybe as a first approximation, you say, okay, here's two things in three-dimensional space. See how
Yeah,
close they
right.
are? See, they're both the same direction, all that kind of stuff. Now, start adding extra dimensions onto that, and then you can start to realize just how complex these databases are and how they're mapping to each other.
Yeah.
So I'm like, okay, I got that. And then I started to go into like the different types of vector database technology that they use. And I don't know, I picked up a lot of stuff. I also saw lots of areas how the vector database engineer, the RAG engineer, is not going to catch the problems that are inherent in the data that's going in there.
Yeah.
You have to have a
Right.
whole separate person who understands the data and even understands how it could be misconstrued by the AI.
Yeah.
And so that's almost a different skill set than the RAG
different
database.
skill set.
It's not a technical
Yeah.
skill set; it's something else. And so I
Yeah.
started thinking about it. So now, yeah, I went down a rabbit hole and I was going into RAG. I have a much better understanding today than I did on Sunday,
Yeah.
but I couldn't do the job. I just conceptually
Yeah.
understand it.
Well, and I have the most cursory understanding of it. So the reason I say 3D space is that's all I can see in my head.
Yeah.
And so I don't have the math or the insight into actually understand what's actually going on. So what I do then is I tell AI that I've got this set of data. In this particular case, it's Q&A for like a phone person that you're talking to. And I said, I want you to format this in a way that 11 Labs would like to use this and how it sees it. And it knows 11 Labs. It says, yeah, I'm going to format it in these question and answer pairs. And then what I'm going to put indexes based on each question. So that'll help it group it together when it translates. And I'm like, okay, I don't really understand it, but okay, you seem like you do. So I'm going to have to assume you know what you're doing in this case.
You got tokens and then you got chunks.
Mm-hmm.
And the chunks, I believe, are what they actually vectorize.
Okay.
And then somehow the chunk is given a vector and other chunks are given other vectors. And then it's able to do a mathematical calculation to figure out when things are close together.
Yeah.
And that gives it its pool of potential responses, right? And then it figures things out that way, as opposed to the typical LLM, which is just going out and doing probability, right?
Yeah, and that comes into transformers and how it works, and it just gets so deep down the rabbit hole.
Side note real quick, I think they said Chat 5 has 10 times the processing power, I think it's 10 times is what they claim, the processing power of Chat 4. People are saying
Yeah.
it's probably closer to twice, not 10 times. But they
Yeah.
had to build 100 times the technical background to be able to do that 10 times increase.
Mm-hmm.
So
'Cause the
scalability
width
wise,
scales.
we're gonna have
Yeah.
we're gonna have a scale problem pretty soon. Actually, we already do. And
Yeah.
with the power consumption we're talking about, so what I asked is are transformers scalable long term, or are we going to need another technological breakthrough? Either
Yeah.
transformers become way more efficient, or we just move away from Transformers to something new.
Well, yeah, I think they're arguing that now, or thinking, because that's where the reasoning models come into place. It can go down multiple different paths, and apparently the model itself can assign how much confidence I have and this is the right answer.
Mhm.
And so what it does is it starts to just kill a lot of the ones that have low confidence, like just like a human does. It's like, no, I don't think that's let me go over here, right?
Yep.
And you have multiple paths, and so apparently I just was watching a video today. They were talking about how, and this is, I have no details on this, but how they're now using, with simpler models, using a different algorithm, they can actually get better answers than bigger models. So they're like, this is how we're probably going to be scaling in the
Isn't
short-term
this-
future.
So we've talked about this in the past. To be able to hold multiple ideas in your head at the same time.
Yeah.
So you tell me something and I'm trying to reason it out. I don't go down one reasoning path. I go down, well, it could be this, or it could be this, or it could be this.
Yeah.
And I put a little bit of thought into each, and I say, well, it's not option C. That the chances of it being that are way out there. And now I've
Yeah,
got
right.
options A and B, and I put some more thought into it, and I finally get to a point where I go, well, option B is beginning to break down. Let me drop it. Now I'll put all my
Yeah.
effort into option A. I
Mhm,
think this
mhm.
is the way. I don't want to say a properly working human mind, but an efficiently working human mind, I think, works.
Yeah. That's yeah.